Hello, this is Gengift here, and we're back with Immersive Engineering Testing Edition for the computer. My entire idea that I described yesterday is broken. Because in my experience with, we run over here and come up here, these batteries, and then the batteries over here, did I actually label the banks? Nope, I only labeled the banks over there. Whatever, doesn't matter. Is that they would discharge from the top and then charge back up from the bottom. And I designed all the circuitry based off of that assumption. So, I tested that assumption. Switch. Thank you. Oh my god. Wow, lag. Okay. Oh, this should be interesting. So, that's on, and then we see how it charges. Do. Yeah! Turn that on. Discharge. Yeah, it's not doing it the way I expected. Crap. I have to redesign everything I designed in the month of December, which took me a month. Now, it can still be automated, but it can't be this setup. So yeah, I had set this system up to test it. I was going to use this logic unit right here for the testing, and then do a bunch of switching stuff and get that to work that way. But, well, my theory and how I was expecting this to work doesn't. Oh god, no. Have I just made an infinite loop that causes lag? Yes, I have. Haven't I? Yep. I might have just crashed the server. Ha! Brilliant me. So yeah. Drat. I'm gonna have to redesign everything. There's ways around this because I can work with it, but the problem is the way I have to redesign it. The way I have to redesign it doesn't work with this setup. At all. Well, actually, if I move some things around, I can make it work, because I'm going to have... Oh, no, it doesn't work. Because the way it is, I can't get... one, all of these have the wrong connectors on them. I can't get a connection there and there because they're too close together. I would have to move this to there and move it all out, which is doable. Because this requires 2 outputs. Because now that we're back here, these have a signal threshold. So, depending on whether they're sensitive or not, I don't know if this sends out a charge based on its state of charge. I don't know if it sends out a signal strength based on its state of charge. Although we can test that because it's not likely to be full. Although I'm not actually getting a status off it. Nope, we go. Okay. So, if in theory, we'll test this right now. It's at 3, so if I set the signal threshold to 7, does it shut? It does! It does. Okay. So these things do send out a signal based on their state of charge. Because now what I'm going to need to do is basically sum it up as this. There we go. So instead of trying to use paint, I remembered I have this whiteboard handy. So I can draw and use it to describe everything. So we'll put four. Well, that's an ugly box. Okay, maybe I shouldn't draw. And hopefully I don't knock the entire stand over. So each box is one of those batteries. Now my assumption was that, and we'll call this 1, 2, 3, 4, 5, 6, 7, 8. Now my assumption based off the batteries I have sitting over here, up here in this area, was that everything would discharge and charge up, as was going to show here. Because what those were doing is they were charging from 8, so this would charge first, and then it would go to 7. Then from 7 would go to 6, and from 6 would go to 5, then from 5 would go to 4, and then 4 would go to 3. 3 was going to 2, and 2 was going to 1. And then when it discharged, it was doing this. 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7, 7 to 8. That's what it was doing up in that area up here. So that's what these were doing. The thing is with these didn't have a huge power draw. So if we go over here and we click on this, we can see how much power is actually being drawn from these batteries to various different parts. So that's over here going to there, which is going over to there. This is charging these. Then these connect over to there, go to this transformer, which is going there, and apparently not actually doing anything. Going up to there, which is then going to this battery. We have no flux going to the equipment because it's not doing anything. Interior lighting is drawing 115. This is actually a charge. Then we come over here. That is doing nothing. And the street lights are doing nothing because they're not on. So that's how that's set up. And, well, when it's only doing 154 flux a tick, that's actually not that much of a load. Downstairs, we're having as much of a load as we can pull or take. And as a result, it is not doing the nice pattern. So as a result, that is not doing the pattern that I described here. And because it breaks what I was assuming to be the case, it broke my entire design I worked on for December. So I've got to redesign everything. Now the nice thing is, with these redstone connectors, so let's throw a box here. This is looking top down onto the box. So we're looking at the top of the box. There's only 4 ports, basically. So I have to have one side where power goes in, one side where power goes out. And then I have to have 2 spots for signal, one there and one there. The nice thing is, because those connectors, because this is emitting a signal based off of the charge of the battery, so the annoying thing is the 15 strength, so hooray, that makes it easy dividing 15 into 100%, but whatever. So let's draw 2 lines here, 1 and 15. I can set one down here and another one up here, that I can do logic based off of the difference. And that is what I'm going to end up having to do. And then I'm going to have to find some way to combine this information into a display, which is going to be fun. So the nice thing is I have a way of measuring the difference, so I can still set it up so that it can be automatically charged and discharged without any actual outside input from a player, just having it all automated with the logic circuits. It just means I have a heck of a lot more work to do it with now. Because it's not this simple solution that I was expecting and had designed for. It is something completely different that I did not expect and did not design for, so I have to scrap everything and restart. And this color is barely visible on that. So, great. Yeah, so my entire plan was destroyed in testing. I have to come up with a completely new one, which will probably take me another month before I can start building anything. And I have to reconfigure the substation to get it to actually truly work. So, because currently I don't have all four sides accessible for inputs and outputs. Yeah, it's doable. If you're wondering why I keep looking over there, because that's where my office is a mess right now. That's where the recording software is set up. Ooh, it's going into infinity. And so that's why I keep looking over there to make sure it's working right. Because I usually don't use the webcam. So yeah, so much for that nice and easy plan. I have to come up with something else that is much different. And because you can't reprogram the sensitivity of those connections up here for the redstone signals, it's not going to be as programmable as I was hoping for. But oh well. Basically, it's going to be based off of a delay between these two signals here. So, if both of the signals are on, so like when it's above this side and above this side, the charge can automatically be shut off, and it reads back as that battery's being charged to whatever amount it's set to, which can be set basically in the hardware at various different points. So, and then when both signals are off, so when this signal's down over here and this signal's down over here, this portion here will trigger the computer to recharge the battery. And in this gap, it'll keep recharging until both of these are back on again. So as long as this signal here is on, but this signal is off, it'll charge. Yeah, awful spelling there. It'll charge. My God, you can barely see that. I really need to find a different color. So yeah, and then once it gets up to here, when both of these signals are on, it stops charging. And that's what it's going to do. Now, I can send back readings that will tell the computer how charged the battery pack is overall based off of the 8 batteries. And I can it can be programmed digitally via memory systems in a way, via some interesting zero binary programming. It can be set up to start charging the substation after 4 of the batteries are down here, and then stop when they're all up here. Or it can be set up for when 6 of the batteries are empty, or it can be set up to start when the entire battery bank is empty. And that way it isn't constantly switching between charging and not charging, because otherwise if you don't have the gap to tell if it's charged or not, it'll just keep charging. And then stop charging, and then start charging again, and stop charging again, and then you have server lag like apparently we're experiencing today. So yeah, basically my plan was ruined, and I have to come up with a new one. My new general premise, I think, is pretty good. I'm just going to have to use Turing Complete to map everything out the way I want it to work. Which shouldn't... It's not going to be hard. It's not a hard thing to do, it's just time consuming. And so I need to sit down and do that, probably starting this weekend. After these videos go up, because the first video goes up Saturday, and this video will be going up Sunday. So yeah. Beautiful. My messy as heck office. See ya. No, it's not really messy. It's just cluttered. Messy implies that there's a lot of food and everything sitting in everywhere, and that's not the case. I do eat in here, but I take that stuff out quickly. I don't want bugs in my office. Paper works, though. Crap like this. What is this? Need to know. Go over there. Have fun. Don't forget to like, share, and subscribe, and we'll see you next time. Hello, I hope you've enjoyed the video. Don't forget to like, share, and subscribe, and hit the bell icon and all that wonderful fun stuff, because subscribing to YouTube is no longer enough. Hit all the things. Hit the like button. Like the comments. Comment multiple times. And don't forget to share. But subscribe and hit the bell. See you next time. Bye.
I think our tank exploded. Whee! There it goes.
The plane or our tank?
Well, there's a tank flying through the sky.